So this is our solution which we propose, Polyglot. So what this solution does is, in our modern day coding systems, हमारे पास बहुत सारे languages रहते हैं. For example, if आप एक web app बना रहे हैं, so we have a different language for front end, a different language for back end. And अगर कोई back end में code है, कोई एक variable को हम mention कर रहे हैं and उसका ही एक variable रेफर कर रहे हैं उसी वेरिएबल को हम फ्रंट एंड में, तो अगर हम नेम चेंज करते हैं बैक एंड में, तो फ्रंट एंड में भी वो डिपेंडेंसीज चेंज हो जाती है, जिसकी वजह से बहुत सारे एरर्स आते हैं एंड उसको मैप करना एज ऑफ नाउ बहुत मुश्किल है. एंड बहुत सारे एजेंट्स इसमें फेल हो जाते हैं. सो व्हाट आवर सोल्यूशन डज इज मैप दोज रन टाइम एंड स्टैटिक डिपेंडेंसीज एंड उसको आउटपुट दिखाता है. सो हियर इज अ गिटहब लॉगिन. सो गिटहब लॉगिन इसके लिए सो दैट वी कैन टेक यूजर्स फॉर दिस स्कैनिंग पर्पसेस. तो यहाँ पे ये डैशबोर्ड है. तो हम अपलोड रेपोज पे जाएंगे. सो अगर आई डू ब्राउज माई रेपोजिटरी, तो आई कैन सी एज अ यूजर माई रेपोजिटरी, ऑल माई रेपोजिटरीज. फॉर एग्जाम्पल, आई सिलेक्ट this repository itself, that is SI is ByteCamp. Also we have GitHub URL. For example, you don't have your own repository, you have your friend's repository, so you can use the URL of that repository. Then we have local path for if you have a code base on your local machine, so you can use that code base to here. And then you can see you have to just paste the absolute path and then scan local repository. So now I have browsed essays bytecamp. Then I'll scan and build the graph. So you can see as it is scanning right now, and we also have dark mode and light mode. So what are we doing here is, we are using, instead of Postgres or any traditional database, we are using a graph database, that is Neo4j. So now what is the advantage of using this database? We are breaking our folders into, for example, there is a file which has a code. Now that code is can be divided into functions, API endpoints, etc. So we create a node of we have a node of file type, API endpoint type, and total 8 to 9 types of node we have. So we can map those nodes, like where those nodes are dependent. Now, as you can see, the scan is has been done, and you can see the main directories in that repo, that is AI engine, backend, docs, and frontend. So if I go to frontend and select any of the uh, for example, webbook, any of those files, and select. So now यहाँ पे आपको दिख सकता है कि ये फाइल कहाँ कहाँ पे कनेक्ट हो रही है. लाइक ये फाइल जिस जिस फाइल से कनेक्ट हो रही है वो दिख रहा है. नाउ इफ आई सिलेक्ट अ लाइन ऑफ कोड, तो वो लाइन ऑफ कोड से क्या क्या इफेक्ट हो रहा है, दैट विल बी जनरेटेड बाय अ एआई इंजन, दैट इज LLM. तो अभी वो पार्ट हो रहा है, वो जनरेट हो रहा है. Meanwhile, I'll tell you what is the use of that. हाँ, तो यहाँ पे क्या हो रहा है कि instead of scanning whole code base, what we are doing is we are only taking the impacted nodes, and for this we are using the Neo4j database. So the impacted nodes are then fed to LLM. So only those impacted nodes are scanned instead of the entire code base. And after scanning those files, it shows where are the dependencies. For example, I have highlighted this line. So this line affects which files that will be generated over here. So it will take a while to generate. Uh, so what else it does is uses BFS to reduce the compute time. If we have a bigger code base, lakhs of line of code, so we use BFS for that to reduce the commit. So now you can see we have a medium type of affected file, where it is and how it is affected, that is generated by LLM. Then low effect of this file and many more. So this was one of the feature. Then we have the graph view. In the graph view, you can see all the files and where are they connected. For example, this file, and this, if I click on this file, you can see what are the inner local dependencies in that file, like other features, for example, patch service, workspace service, etc. This was the local view, and this is the total overview. Now, if we go to file, this is the front end test AI engine. So this is an interactive graph for the user to visualize the entire code base. Uh, Now in the filters we have like only AI engine. Uh, Sorry, we have hidden the AI engine. Now we have hidden the database. Now we have hidden the backend. Only front end is there. Now only test is there. So if, these filters also work, and this is for JavaScript language. We have implemented other languages too, but now the filter is only for JavaScript, so we can see JavaScript. Now here is the chatbot. We can ask like API test.js. If I type API test.js, then you can see it shows the file name and its directory. If I send it, then the AI will LLM will generate the specific response, like what are the dependencies of this file, where are they mapped, and how much is the risk. So here is the response. You can see now. Now, for example, I want to edit something. For example, if I want to change the name of edge to uh, edges to my edges, so this edit will effect will create what effect will be generated. Uh, ये edit ये edit से क्या impact होगा? So we can see that impact preview impact. So now the AI LLM behind this will analyze uh, what are the dependencies that are getting changed because of these two characters. So that will be generated, and if जो change हमने किया वो अच्छा लगा, if that is causing less dependency, we can click on this and save it. So एक GitHub का API use करके directly repo में वो changes reflect हो जाएंगे, but you have to give a consent for that. Now you can see if I change edges to my edges, these are the new dependencies and all. If I acknowledge this and save, so what will happen is that in my GitHub, wherever there is edges, all the edges will change to my edges, and this change will be reflected in my GitHub immediately using some API. Now, this was our solution. Thank you.